magpadala ng solution. And ako, I say yes, in principle, okay lang. Ang nangyayari lang kasi talaga minsan, well, as you know, nung mga mission ko, nung mga other things that I do, so talagang hindi nakakaligtaan ko na hindi talaga na kukuhaan ng time eh. So at least ito for sessions like this, nag-focus ako. So, unahin natin to. Um, O is the circumcenter of ABC. D is the midpoint of AB. E the centroid. So of ACD naman. Prove that CD is perpendicular to OE if and only if AB is equal to AC. All right. So, well, perpendicularity kasi can be stated in terms of the dot product being zero. So nung vector CD dot OE being zero, so that's what captures perpendicularity. So I guess, yeah, center O as the origin makes sense. And then let's label those vectors A, B, and C. And then because O is the circumcenter, so those three vectors, small a, B, C, are equal to the circumradius, so they're equal. And then OD, this is the D is the midpoint of A and B. So yeah, A plus B over 2. And this is, I suppose, what you're defining as the vector D. Now, E, on the other hand, is the centroid of triangle ACD. And we were able to generate this nice property that this vector is the sum of the three vectors going to the three vertices and then 1/3, so divided by 3. So A plus C plus D over 3, and then plug in D, which is A plus B over 2. So we're going to get 2C, yes, and then 2A plus A, so 3A, and then B, and then over 6, this is OE. And then OE dot CD is equal to 0 if and only if, all right, this dot product is equal to 0. So 2C plus 3A plus B over 6 dot CD, which is D minus C. And then D is A plus B over 2 minus C, and then multiplied by 6 and 2, so A plus B minus 2C. And then, although not necessarily this part where,
Ba't po parang after mga 15 lines po, nag-sideways na po yung pagsulat ko?
ano yan? Sorry, what happened?
Sa mga 15 lines po, parang nag-sideways po yung pagsulat.
I mean, itong part where the length of vector A is, you denoted it by small a, and then small b and small c for the lengths of the vectors. But those are congruent vectors. They have the same length. So you could have maybe used big R. Okay, but although apparently, I'm still waking up the drawing pen. So I'll see 3a squared. Okay, I get, okay, 3a squared. Hmm. Okay, I'm gonna say this part is correct. OE dot CD is equal to 0, equivalent to that dot product being equal to 0. So this part, that's correct. Okay. And what I surmise you did here is you expanded that dot product. However, we got to be clear about what we're really multiplying, and what we're multiplying are vectors. And the multiplication that we're doing is dot multiplication. So if you apply FOIL, so yeah, this makes sense. So that's going to give us 3a dot a, 3a dot a. And we can use this property that when you have a vector and we take its dot product with itself, that's going to be the square of the length of vector v. So, all right, this is going to be the length of A squared, but the length of A, you denoted it by small a, although that's really big R. A equals B equals C, which is the circumradius, then this really is going to be big R squared. However, here, when you apply the continuation of FOIL here, okay, that's 3a dot b. And I seem to, it feels like this is what that corresponds to 3ab. However, unfortunately, it's not. A dot b is a scalar, not a vector, but it's not equal to ab. All right. So that's where this breaks down. So the dot product of two vectors is not the product of the lengths. In fact, let me point out where the relevant discussion is. One of the property that we are probably gonna need to use here is the following here. Okay, see that thing in highlighted in green? The dot product is equal to the product of the lengths multiplied by the cosine of the angle between them. So going back here, okay, A dot B is not the product of the lengths AB, but rather A dot B is equal to the length of A multiplied by the length of B multiplied by the cosine of theta, where just to be clear, theta is the angle between the two vectors A and B. So, or in other words, A dot B is equal to the length of vector A, that's small a, and then here small b, and then cosine of theta. So there's that missing factor there, cosine theta. And so when you carry on with the other dot products, we anticipate that you should take into consideration the angles between A and C, and the angle between B and C. So that's gonna have to enter the picture here.
Pero in the very end naman po, it will all cancel out.
All right, it will cancel out, but that's something that you would have to show. So again, let's continue and you just see where this would go to. Okay. So I'm not gonna write down the arrows anymore. So all right, we have 3a dot a, and then plus 3a dot b, and then 3 minus 6 A dot C. Okay, now the turn of this B. And then B dot A, but then that's the same as A dot B. And then B dot B, so plus B dot B. And then B with 2C, so we have minus 2 B dot C. Okay, and then finally, it's a turn of this 2C to be distributed, 2C times A, so we have plus 2A dot C, and then 2C and B, so plus 2B dot C, and finally minus 4 C dot C equals 0. And this is equivalent to, all right, 3 and then A squared plus B squared minus 4 C squared plus 4 A dot B minus 4 A dot C, and then minus 2B dot C plus 2B dot C is equal to 0. But then this part, that's R squared, that's R squared, that's R squared, and we happen to have the good fortune where the coefficients are 3 plus 1 minus 4. And so the only thing that's going to be left here is this. And so we end up with the following, okay? 4, then you can cancel 4. So we end up with A dot B minus A dot C is equal to 0. Okay, and then what's the equivalent condition? Oh, AB is equal to AC. So isosceles triangle now. AB minus AC. So try natin try to capture AB equal to AC. How exactly? Well, okay. We're talking about lengths here. Okay. So AB equals AC. Also, in terms of the length, so this means so the square. And then the length of segment AB is the same as the length of vector A minus B. And then this is A minus C. All right. So lagay natin dito. AB equals AC if and only if, ayan yan, A minus B squared equals A minus C squared. And then, oh, hey, we have the square of the length of vector. That means we're talking about the dot product. A minus B dot A minus B equals A minus C dot A minus C. So what this shows is that, ayun, marami pa tayong kailangan i-thresh out dito. All right, but then this is equivalent to, well, we see there are things that are going to cancel on both sides. So you have A dot A, and then minus B dot A minus A dot B, so minus 2A dot B, and then plus B dot B equals something similar, A dot A minus 2A dot C plus C dot C, and then mangyari ito, the square of the length of A, but that's the circumradius squared. This is also the square of the circumradius. So with this, so the only thing that's going to survive would be this, and then that. And then when you divide by -2, so that you get A dot B equals A dot C, which you recognize to be what we have here. All right. So using so from so actually we just need to tie them up together. All right. So what we've shown is that OE and CD are perpendicular. So we've shown, okay, OE and CD are perpendicular if and only if A dot B equals A dot C. And then in part two, from the panel on the right side, we've shown that AB equals AC if and only if, hey, it's something similar. A dot B equals A dot C. And so therefore, we can conclude that indeed OE and CD are perpendicular if and only if AB equals AC. All right. So I think Joshua, what did you in was in lang no, ano, no, multiplication ng vectors. All right. One of the things that I guard my students against when it comes to multiplication of vectors is that be careful with using exponents kasi um, if you recall, although we have briefly touched the topic, there's also this multiplication called cross multiplication, aside from dot multiplication. So the problem kasi with a squared, when you write something down like this is this equal to a dot a or a cross a? It's not clear, right? That's because there are two ways to carry out multiplication of vectors, which is why we should never use exponents unless we clarify, in this solution, the exponents that I'm using here pertain to dot multiplication, or this refers to cross multiplication. But the thing is, in general, you'd have to point out what you mean because there's
But
no universal usage of exponents for
what if there are
vectors.
two kinds of what if we invent two kinds of exponents po? Dot exponent and cross exponents or
Yeah, sure. You could always do that. Okay, if you, I'm sure baka meron ma. It's just that it's seldom used. Okay, but again, ultimately, you could always define it in your solution. Let exponents be exponents for dot multiplication or exponents for cross multiplication. Or if you're going to use up your own notation, then go ahead. But that's also perfectly all right. Let's see your other solution for March 11. Ito naman, I showed that the perpendicular bisectors of a triangle are concurrent. Parang may kinalaman dun sa problem natin kanina, meron tayong orthocenter. So ABC triangle and O the intersection of, ayun, the perpendicular bisectors of OD and OE. Kasi we don't know yet that OF is the perpendicular bisector of AB. Kasi, well, ipuprove pa nga lang eh. Okay, so let me draw something para madaling masundan. BC and CA. So A, B, C. OD is on BC. And this must be where point E is. Okay. So let me check. All right, OD is on BC and OE is on CA. Let F be the midpoint of AB. And then take O as the origin. The position vectors of both A, B, C are, all right, so A, B, and C. As for D, E, F, we have B plus C over 2, C plus A over 2, B plus A over 2, respectively. All right, so OD is perpendicular to BC, so OD dot BC is 0, correct. Okay, and then OD is, so vector D, which is B plus C over 2, and then BC is C minus B. So, all right, C squared minus B squared. So dito we should declare that okay. So note exponents here are for dot products. Okay. So that's all right, equation 1. Then likewise, OE and CA, so C squared minus A squared over 2. And then if you add 1 and 2, yeah, A squared minus B squared, which also means A dot B over 2 plus dot B minus A is equal to 0. But then that means OF dot AB is 0. So that means OF is a perpendicular bisector and O is the concurrency point of all the perpendicular bisectors. Therefore, all perpendicular bisectors are concurrent. All right. Okay. Yay. So ang magko-comment ko na lang dito ay maglalagay ako ng -1 kasi this is confusing. Is this March 1 or March 11? Ayan. That's confusing.
It destroyed the entire proof po.
Yes. Joshua, the entire proof is invalidated by that confusing date.
May ano po yung buong ano po, may thesis po siya, tapos binagsak po kasi yung pag-color po ng graph nung past.
Yes, confusing. Hindi ko alam, is this red or parang, is this light blue or aqua blue? Mga ganon. Okay. Okay. So, syempre, matagal na natin dito nagagawa. So, babalik tayo dun sa nitpicking of mga pang-asar na nitpicking ng solution. Okay.
Ano po, when the students get perfect.
Yeah, hahanap tayo ng okay. Alright. Hanap tayo ng may error dyan somewhere. Okay. Tapos, isa pa. Is this CO or CU? Ayan, concurrent ba yun or concurrent?
Concurrent.
Concurrent. Okay.
Completely proof invalid.
Yeah. Okay. Hey, you said something just now. Ano to? Something you want us to look into?
Yes po.
All right. So sige, tignan natin na not necessarily about vectors, pero I suppose nakita niyo to and this has been bugging you. Tama ba? Hindi niyo
Opo.
Okay. Sige. Okay. April 7. Tignan natin. Ano to? All right, the tangents at AB to circle ABC meet at T. And then the line through T parallel to AC meets BC at D. And then prove that AD equals CD. Oh, interesting. Okay, get it out. I'm gonna try to...
Meron po dyan cyclic quadrilateral.
Clue
lang mo.
Sige, walang clue. Okay? Walang clue. Pero mamaya, if hindi ka ma-figure out, ganito. Prove that AD is equal to CD. Now, nung thought process ko dito, you can show that a triangle is isosceles by arguing in terms of sides.
Yes.
Or arguing in terms of angles. Ngayon, sa naisip ko, wala kasi tayong information about sides eh. And the thing is, even though the problem statement doesn't say anything explicitly about angles, my assessment of this is that this is all going to be in terms of angles. Kasi bakit? meron tayong parallel lines eh. Eh di ba kapag meron tayong parallel lines and then you draw a transversal, meron na tayo agad magko-conclude ng mga angles which are equal, yun, alternate interior angles or itong corresponding angles na yon. So you have a parallelism situation here. So I'm thinking this is in terms of angles. And then also tangent C can be explained as well in terms of angles. So I'm just gonna draw some marks here, and then hopefully it becomes productive. Pero this angle,
Opo.
I'm gonna
I think
call. Yes, Joshua?
di ba po yung ano din yung mga inscribed na mga arcs?
Oo, pwede din may mga ganon. May mga ganon din.
Kasi
Alright.
na-conclude ko po marami na pero naisip ko po ngayon baka yung yan yung isa po sa yung in-inscribe ng mga tangent secant.
Kasi meron tayong tangent so dapat magamit natin yon. Magamit natin yon dapat. But now that you reminded me, this is one property that I'm thinking. So anyway, so since theta yon, ang goal natin is itong angle na to, we want to show that that's also theta.
Kailangan mo po or yung isa po?
Hindi kasi AD is equal, oh sorry. Ano ba yan? Okay, AD is equal to CD. Okay, thanks Okay, ito, AD, CD. So ito pala ng angle na dapat theta din. Okay. But because of parallelism, nung question mark na yon, same siya dito. Okay, same siya doon. Okay, kasi AC and TD, they're parallel to each other. Okay. One of the properties that I remember from inscribed angles, ganito. Alright, so kunwari, meron tayong itong 2 points na to. Okay. So any inscribed angle, kunwari, if that's theta, then any other inscribed angle, theta then. Okay. But one other angle I remember being theta is the following. If we take one of the two endpoints, it actually doesn't matter which one. And then if we draw the tangent, gamit to ng color.
Color white po para kita.
Sige nga, let's see. All right. Yeah. Sure. Okay. So helpful. Okay. So educational. Ng green parang hindi masyado ma-distinguish sa blue. Let's try something which stands in greater contrast.
Kaya po yung darker.
Darker green mas mahirap. Okay. Anyway, ito isa pa.
Darker for more contrast.
Darker
Darker blue po for more contrast.
Darker blue. Actually, I don't have any darker blue kasi ang ginamit ko okay, the same color for contrast. Andito na. All right. So if we connect, that angle is also going to be theta. Theta rin yun. Okay. So with the theta angle marked as we did, okay. So this it's this angle theta. Okay. So and then so what that means is that this angle, this is also going to be theta. Theta din yun.
Saka isa po kasi tangent.
Tangent. So theta din yun. Okay, so ito, wait. This is theta, and ito din, for sure, theta din yun.
Parang lahat po yata theta.
Theta. So, nung
Alternate external angles. Ay, yung remote angle theorem.
Okay. And then,
alam ko na po. So if we can prove that yung, ano ba?
Which quadrilateral?
If we can prove po that BD, wait a minute. Tama
Yeah,
pala
sige.
po. Means pala, since ganun, cyclic quadrilateral nga yun. Tsaka also
Which
po,
one?
yung as a consequence yun. Pero yung ano po, yung wait, yung ano ko, yung BDT, if we can prove that that is theta, then everything is solved.
Yes, if we could show that BDT is theta. But
Or if we can prove that BDAT is cyclic, which I
yeah,
think is
okay. If BDAT is cyclic,
impossible.
syempre, how?
Tang, 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 tang. Oo, so similar triangles. Yung
Sige.
BD something and then BCA.
Wait, BCA and
BD intersection. Oh, wait, yun na pala. I did it. Kasi parallelized po yun. BDT is congruent to theta.
mm-hmm. Ayun. Yes. BDT is theta.
And then because of the remote angle theorem, the what? Oh, wait a minute.
So ganito, lahat ng mga theta na nakalagay dito, these are all well supported.
Opo.
So tama lahat ng theta.
So because
So,
of that, doesn't that mean na it's already ano po sa what do you call it? Cyclic?
the BDAT cyclic, which means the double question mark here, the double question mark is therefore now theta kasi it's equal to that. The theta with the check mark. Alright.
Ayan. Because parallel lines. Theta rin yun.
So theta rin yun, the one at A. Alright, so now let's write it down properly. So, ayan, solve that. Okay, so let angle AC let angle ACB be theta. Okay, and then dito papasok ng tangent C since AB, T, okay, since TB and TA are tangent to the circle
Kami na yata po na proof, so ang hirap na i-track down net.
at A and B, then angle TBA is equal to angle TAB, also theta. Since TD is parallel to AC, then angle TDB, TD parang teddy bear, TDB equals angle AC ACD equals theta.
Teddy bear equals acid.
Acid. Oh, fun. All right. So this implies, kasi kung puro since and then since, so gamit naman tayo ng ibang word. This implies that angle,
Gamitin niya po yung three dot po na nakabaliktad.
no, pwede din. All right. TDB equals theta, and this is angle TAB.
Gawin niyo po for more variety. May because, tapos due to, may mga
Which means TADB is a cyclic quadrilateral. Consequently, the angle ADT equals angle ABT, which is theta. So ito, theta nung 2 question marks. Again, okay. Wait, recall that, okay, TD is parallel to AC. So angle DAC equals angle ADT. Okay, and then DAC. Okay, because ayan na, DAC and angle AC, DCA. Then AD is equal to CD. There we go. All right.
Thank you po.
All right.
Nice.
Nice. Okay. Balikan natin ng ano nung other vector multiplication that we were discussing last time. So wait, no mga try. Ito, okay na to.
Kung may dot product po and cross product na po yung vectors, yung mga tensors po doon, do they have some sort of special product?
That I do not know. Okay. Mga tensor products, that's unfamiliar territory to me.
Apo.
Okay. So let's mark OD. Ito nung second try. All right. I think this is what we just addressed just a while back. CDOE if and only if AB equals AC. So we still have itong ano, points in space. And then, all right, and then I don't know if you want, you could still continue. I don't know if you finished this. I show using vectors that the angle bisectors are compared. So medyo di ko na matandaan. Okay. But always a good exercise to sort of finish the story because we've shown concurrency using vectors for some special segments already involved in the trial.
Saka ano po ba
Okay.
yung artificial intelligence na ChatGPT? Nasa-solve din na po yung mga geometry problems kahit na may figure.
Oh wow. All right. But well, I haven't tried it yet. Di ko pa na to try on ChatGPT. I've just been hearing about it.
Meron na po siya na-solve na Olympiad problem. Try na po para ano.
Eventually, kaya, parang we imagine magkakaya din yan. Kasi, yung mga options na titignan niya, may mga Olympiad problems which are more basic than some of the other Olympiad problems. Even in the IMO, say no problem number 1. So it would be more basic compared to, for example, problem number 6. So yeah, but I don't know if kaya na niya nung mga difficult IMO problems. All right. Anyway, ito cross product. So you've done this in some of your physics classes, right?
Yung cross products po.
Cross products. You've done, so nung computations are things that you've already done before, right?
Computations lang po.
Sorry, what's that?
Computations lang po.
Yeah, computation. So we don't have to go too much into it anymore. And then the computation was done similar to what I'm illustrating here in terms of tama ba? Same then, IJK above, and then the components of vector A in the second row. So ganito din ba? Some of these in terms of some determinants.
Boy, yung parang something of minors. Is there a term for it?
All right, minors. Yes. Determinant minors. All right. Okay, but regards to the name, okay, so it looks like this. Some properties of dot products which and cross products which distinguish them from each other. Well, when you take the dot product, the result is a scalar, but when you take a cross product, the result is going to be, as you can see here, it's going to be a vector. And the dot product, we can take it for two-dimensional vectors, for three-dimensional vectors, for four-dimensional vectors, as long as the two vectors have the same number of components. The result is always going to be a scalar. However, the cross product is defined only for vectors, which have three components. The result being also a vector, which will have three components. But A cross B and B cross A are going to turn out to be not the same. So cross multiplication is not commutative, rather it's anti-commutative because A cross B and B cross A, they're going to be negatives of each other. Okay, so that's property number one here, and then property number two. So C A cross B, where C here is a scalar, so that can be taken out, and we only need worry about the actual vectors themselves. And then numbers 3 and 4 talk about a kind of distributive property of cross multiplication, sorry, cross products with addition of vectors. The proof involves tedious algebra, but essentially what 2, 3, and 4 tell us is that, hey, we can also do certain calculations as if we are carrying out algebraic, high school algebraic computations. Kasi mayroong distributive property and wala lang commutative property. So we always have to be careful about the order. And then number 5. So this is a combination of, well, what happens when you do a dot product and a cross product. So here, A dot B cross C, and then A cross B dot C. So the proof of number 5 is also going to involve um, a little bit of algebra, okay, but that's gonna be the left side and the right side are gonna be the same. Oh, for me, a way to remember number 5 is that so if you write down A, B, and C from left to right, say whether it's dot or cross, or it's cross and then dot, then the result is gonna be the same. Hindi magbabago, even if you switch the dot and cross. But then, of course, you need to take the cross first in each case. Because if you were to take the dot product first, that's not going to make sense anymore because, well, A dot B is going to be a scalar rather than a vector. So then you're going to run into trouble taking its cross product with C. Okay. And then number 6 is, well, what if you have 3 cross products? Now, what number 6 tries to address is the question of whether, hey, is cross multiplication associative? So we're gonna see it's not, because otherwise number 6 one would feel if cross multiplication were associative, meaning is this going to be the same as when you take the cross product of A and B first before taking the cross product with C? And the answer is that typically the result's going to be different. And rather than prove the non-associativity, we will just have a look at an example. All right. Okay, but ito. Um, even though the lesson is cross products, I just want to make sure that this is covered. What is I dot I?
Zero.
Not quite.
Oh wait, I squared.
All right. The square of the magnitude. But what's the magnitude of I?
Magnitude of I, 1.
So this is going to be 1. And so likewise, what's j dot j?
J squared. Or 1 din.
1 then. And how about k dot k?
Definitely not 1.
All right. Definitely not 1. Okay. But what about I dot j?
0 because they're all perpendicular.
Yeah. So I dot j, I dot k, and j dot k. 0 because I, j, and k are perpendicular vectors. Now let's talk about cross products. Okay. Something I wasn't able to in the properties of cross products. Okay. Sige, ganito na lang. Let's have a look at I cross I. So this would be 1, 0, 0 cross 1, 0, 0. But tell me, if this is a computation you've already done before, do you remember what the result is? Just in case
Well,
nagawa na ninyo. Pero kung hindi, okay lang.
I know na may ganun po special na product yan. I
Alright, so
think
ito.
one of them is one of J or K.
Sige,
Or
tignan
wala.
natin na. IJK, di ba? Sa ganyan. And then 1, 0, 0, and then 1, 0, 0 ulit. Then how it goes is, di ba, no I, tapos we're gonna take the vector from columns 2 and 3. So that would be the determinant of 0, 0, 0, 0. And then minus j, which is in the second column. So this time, what we're going to do is we're going to take columns 1 and 3. But then that's going to be 1, 1, 0, 0. Then finally, k, which is in column number 3. So what we're going to take is the determinant from columns 1 and 2 this time. So that's going to be 1, 0, 1, 0. What are each of these 3 determinants equal to?
So yung isa, syempre 0. And then the other one is 1 minus 0. Tama ba? Oh, wait. AD minus BC. AD minus BC.
Ito,
ABC.
multiply that, and then multiply that, and then the difference.
It's also 0.
And how about here?
It's 1 minus 1.
Okay, so 0 minus 0, but 7 minus 7 as well. So what we get is a vector, all of whose components are 0. So what we get is the 0 vector. So it's the 0 vector. And then similarly, okay, J cross J is also going to be the 0 vector, and K cross K, that's also going to be the 0 vector. Okay. In fact, okay, V cross V is always going to be the 0 vector. So when I write down a cross product, it is to be assumed that this is a 3-dimensional vector because it's only for these kinds of vectors where cross multiplication makes sense. Okay, so it's not just I cross I and J cross J and K cross K, which are 0, because baka isipin natin, oh, it's because these are very particular special vectors. But really, in general, you take the cross product of a vector with itself, the result is going to be 0. Okay. In contrast, when you take the dot product of a vector with itself, meron pa ring special na mangyayari. V dot V will be the length of V squared. But if you take the cross product of a vector with itself, merong special na mangyayari. This time, the cross product is going to be 0. So here's one way to argue that. Argument 1. Okay, let's say V has components A, B, C. So let's see how the computation is going to look like. So we write down I, J, K, and then the components of V, A, B, C, and then the components of the same vector because it's the same vector. And then when you write it down, I, and then which is in column number 1. So we take what's in the second and third columns, BC, minus J in the second column. So we look at the first and third columns, AC, AC, and then finally, since K is in the third column, we write down this 2 by 2 determinant using the first and second columns, AB, AB. Now, Joshua, what are these three determinants equal to?
So yung first one po is exactly 0 times 0, it's exactly 0 times 5.5 million. And then
Yeah,
the next
okay.
exactly the additive inverse of 0 plus 0,
Okay.
0,
Yeah.
0. And then the last one po is ln of 1.
Okay, so 0. All right. That's because that's what happens when the first and second rows are identical. So we get again the 0 vector. So it's nothing special with ijk, it's with any vector. Here is a second argument. Recall the anti-commutativity, A cross B equals the negative of B cross A, if A and B are vectors. So ngayon, let's put in, let's say A is the vector V and B is the vector V. Then we would have V cross V equals the negative of, hey, V cross V again. And then if you move everything to the other side, so we then end up with twice V cross V is equal to, so dito sa right side, it's not just going to be the 0 vector. So that means V cross V, if you double each of the components of V cross V, the resulting components are going to be 0. So that means, hey, even before you multiply it by 2, then all the components must have already been 0. So V cross V is the 0 vector. So vector with itself, the cross product is going to be 0. Okay. So I cross I, J cross J, and K cross K. But what about, say, I cross J?
I cross G. K or negative
What's
K
that?
ba? It's a K with something negative or something negative or positive K. I just don't remember.
All right. But anyway, so ito, dalian lang natin. This is 1, 0, 0 cross 0, 1, 0. So that is going to be I, J, K, and then 1, 0, 0, 0, 1, 0. Then let's spell it out. I with 0, 0, 1, 0, and then minus J. Actually, as soon as you have one row, all zeros, or one column, all zeros, tapos na usapan. 0 na ng determinant.
Di ba
Ito,
po siya tapos it's only that is the what two of the
yeah, sure, sure. I mean for that particular determinant. Ito. So this is gonna be 0. Same here. It's only the last determinant, which is 1, so we end up with K. So I cross J equals K. In fact, one easy device that's often drawn to remember is if you write down in order I, J, K clockwise. Sorry, yeah, clockwise. I, J, K. This is supposed to capture the fact that I cross J is equal to K. As you follow and then take the cross product of two consecutive vectors, which are following the direction here. So let's say this time you start with J, and then ang susunod would be K. But then to complete the trio, it would be I. So the product is I. Then lastly, K cross I is going to be equal to J. And on the other hand, if you would go the opposite direction, say that you're going clockwise, if you're going to go counterclockwise, or essentially in the opposite direction, so kunwari you start with I, but then going opposite the arrows would, the next one would be K, and then J sana. But since we're not following the arrows, this is not going to be J, but rather negative J. Hey, which is consistent with K cross I is J, so therefore I cross K, due to anti-commutativity, it would be negative J. And then, so yeah, we're just applying anti-commutativity. Okay, so to the question of, is cross multiplication associative? Let's have a look at the following. I cross I cross J compared with the following. I, J, but with cross products, but it's the second and third, which have to be multiplied first. Let's have a look at the first expression, I cross I, and then J. Now, the group is I cross I, so that's going to be the zero vector. And we take the cross product with J. What is that vector going to be, Joshua?
Going to be something.
Mhm.
It's definitely not the one vector. It's probably the only vector that begins with the name with the letter Z.
Z. All right. So it's a zero vector. And then next, I cross, and then I cross J is
Okay.
K. But what's I cross K?
It's the negative J.
All right, negative J. So as you can see here, the results are different. So this is an example which shows that you change the ordering, or you change the grouping of a series in a series of cross products, and then the result's going to be different. So the answer to the question is no. Cross multiplication is not associative. Okay, there are other properties that were mentioned last time, and to be honest, I don't use this property number 6 that often. Sometimes I end up using it, but not so much. But number 5, we're going to encounter this again later. The proof of number 5 is again going to be in terms of algebra. Okay, these are algebraic properties of cross products.
Yung ano po,
What?
yung ano po, painkiller. Prove all 6.
Yes, prove all 6.
Tapos yung test time limit po is 40 minutes.
Okay. So, depende. Kailangan mabilis. Pero, okay. How many minutes again did you mention?
40 minutes po.
40, 40. Pwedeng kayanin. You know what? Pwedeng kayanin.
Pwede
Okay.
kayanin po ganito.
Okay. In fact, halimbawa nung numbers 3, say if you get to prove number 3, parang nung number 4 can be written kasi parang pinagkaiba lang naman ng 3 and 4. In number 3, nahuli nung sum. And in number 4, nauna ng sum. So, assuming you've already proved number 3, you don't have to reinvent the wheel for number 4. A plus B, and then cross C. And the i-rewrite natin na baliktad, negative of C cross A plus B. And this should now be subject to property number 3. Kasi in property number 3, nahuli ng sum eh. So this time, when you continue, you don't have to write down the components na A1, A2, A3, C1, C2, C3. So may mga ganun steps na mapapadala. All right, these are algebraic properties. What I'd like to talk about next are geometric properties of cross products of vectors. Okay, just want to make sure that I do this in order. Okay. The first question that students often ask is, why was a cross product defined the way it was defined? I suppose it's supposed to serve some need, but what is that need? Why define the cross product in the first place? Okay, it's because of the following important property. A cross B is orthogonal to both vectors A and B. Okay. Have I introduced the word orthogonal before?
Orthogonal, perpendicular.
Yeah, it's all right, cool. So it's just another fancy term for perpendicularity. So A
When
cross B
I,
is
when I need to see perpendicular po, but it's for my thesis.
so he's perpendicular. I don't know, for some reason the term orthogonal is used when referring to vectors, but I don't mind if my students talk about the perpendicularity instead of orthogonality of vectors. Okay. So why would it be important to, well, may mga certain geometric applications where given two vectors, we need a third vector which is perpendicular to both the given vectors A and B. And what the cross product gives us is an easy way to come up with something that's orthogonal to A and B. And to prove this, all right, so proof. Ito. Two vectors are orthogonal if and only if their dot product is 0. So for the proof of this, let's take the dot product of A with this cross product. And then our goal is to show that this is going to be 0. So here's what we're going to do. we're going to use one of the properties, one of the algebraic properties. I'm going to write down the three vectors in the same order from left to right, A, B, but there's this property which tells us that you can switch cross and dot. So cross here and dot here, but then we carry out the cross product first. Joshua, do you then see what this is going to be equal to?
It's equal to something, but I just cannot tell what something it is. So, so yung 0 times 0 vector times b is equal to exactly 943. So, yun po yung patapos.
All right. Yeah, 943. So yeah, A cross A. So 0 dot B. So of course, when you the zero vector dot anything is a scalar 0. The zero vector cross anything is the zero vector. Okay, so therefore, A cross B perpendicular to the vector A. And then paano naman ng B? Well, this time it's convenient to write down the dot product in the following manner. Para nung B, magkatabi na sila. So when we write down A, B from left to right, put dot here and then cross here and then switch. So we end up with a vector across itself, B cross B, B cross B. So that's a zero vector dotted with A. So it's a scalar 0. So same conclusion, A dot B, A cross B is perpendicular to the vector B. Okay. Have you in the discussion of the cross product, was this something mentioned to you by your physics teacher in your physics discussion?
Abo.
All right. Did your teacher talk about the right hand rule?
Yes.
All right. Okay.
Yung you will physically break your fingers to put them in awkward positions just to
Oh
display.
yeah. Right. Okay, so I'm not gonna draw it anymore. I'm not gonna illustrate it anymore. Okay, but I am assuming this was a property that was pointed out, pero hindi na na-prove. Bakit? Or did your teacher prove it?
Yung ano po?
Right.
Itong A cross B is orthogonal to both A and B.
Yung semantic reason po, yung bakit the why, hindi naman po, pero parang like is that it? Parang it makes sense. I mean like orthogonal siya to the plane of the two vectors.
Okay. So yeah, that's what the cross product does. So and anyway, because this is a math class, I will try to prove as much as I could. Although of course hindi ko rin naman napuprove lahat kasi ano for example, I just did a little bit of hand waving with some of the algebraic properties and just said that it's just tedious algebra in writing things down in terms of the components. Okay, number 2. Remember this A dot, okay. Let's write this down in a different color for a comparison. So recall that A dot B is equal to the length of A multiplied by the length of B multiplied by the cosine of theta. Where what is theta? Theta is the angle between the vectors A and B. So that's what the angle theta is. Now, this is consistent with the fact that, okay, A dot B, this can be positive, 0, or negative. And then if you look at the right side, cosine theta can be positive, 0, or negative. In fact, this statement is the basis for the fact that A and B are orthogonal if and only if their dot product is 0. All right, because them being orthogonal means that theta is going to be 90 degrees but its cosine would be 0. So the cosine part would be 0 if and only if theta is 90 degrees. So that's equivalent, therefore, to the dot product becoming 0. Okay, now we actually have a similar property for cross products, and it looks like this. A cross B on one side, and then on the right side, it's going to be the length of A, and then the length of B, and then this time it's the sine of theta, where theta is the same angle between the vectors A and B. Now, of course, the way I've written down this statement is incomplete and incorrect. After all, the right side is a scalar, and then the left side is a vector. Okay, so ang kulang dito, what I mean to write down on the left side is not just the cross product A of A cross B, but rather, ayun, the length of A cross B. And A cross B is now, well, A cross B is a vector, but its length is a scalar. So now the left and right sides are now consistent. Okay, and also the angle between two vectors, theta, is supposed to run only from 0 to pi. Okay, when did I first talk about the dot product? I apparently March 11, or maybe before. Or before. Oh, ito, the dot product. So the angle is between 0 degrees and 180 degrees. So an angle in the first and third and second quadrants. Because as you can see in the illustration, with theta smaller compared to the other larger angle. So kasi we have to decide, given two vectors, which of those two angles are we going to choose? Then the choice would always be the smaller one. And so that would mean that the theta can be acute. It can also be obtuse.
It can be
Okay.
it can be acute angle or it can be acute.
Acute or sorry, what I didn't hear?
It can be an acute angle or it can be acute angle.
Oh, okay. If you find obtuse angles cute, also 90-degree angles, yeah, also find them cute. Okay. Also remark, theta is from 0 degrees to 180 degrees. So quadrants 1 all the way to 2. So that means the sine of theta is greater than or equal to 0. Which means that there on the right side, it's not necessary to enclose sine of theta in absolute value bars because, well, sine of theta is going to be non-negative anyway. And, well, why would the right side need to be greater than or equal to 0? Because the left side is the length of a vector. And that's greater than or equal to 0. So the proof of this, unfortunately, is a bit tedious. Um, in fact, the proof of this is not something that I've ever done in class. So I just refer my students to read the notes in the book. Okay. Pero sige nga, let me try doing it here. Okay, proof. Okay, let's have a look at the square on the left. A cross B squared. So this is going to be A cross B dot A cross B. Parang pagsisisihan ko yata ito ah. Ituloy ko ba? Ituloy ko ba? Sige. Okay. Ano lang naman. And disclosure, I've never done this computation before. So tignan natin. Started with ito. Parang kasi nakakalula. Let's call this, parang ang daming vectors na nakikita natin. So what I would do is, let's call this vector C.
Ano po, peak efficiency, yes.
So now we have A cross B dot C. And then which we're going to write as A dot B cross C. Okay, so ngayon tignan natin, what's going to happen to B cross C? Let's write it in orange. Okay, B cross, what is C? C is A cross B. All right, and now dito papasok ng isang property that I hand waved and didn't say much about. This one, number 6.
Sneaky operation.
So ganito, para hindi tayo malito, let's rewrite this in terms of different letters. U cross V cross W. So this is going to be U dot W and then V minus U dot V this time and then W. Observe that A dot C scalar. So halimbawa, if that's 7, then this would just be 7B. So that's why we don't need to put an operation there where the arrow is pointing because that's just scalar multiplication. Okay, so let's continue to the orange computation. Let's go back to orange. So this is now going to be, okay, B dot B A minus B dot A or A dot B and then multiplied to B. Ayun. So now, ibalik na natin siya. So A dot, okay, B dot B, that's the length of B squared, A minus A dot B, scalar, and then B. Okay, so when you carry out the dot product here, itong dot, it would just be A with vector A, and then later on, A with this vector B. Kasi the others are just scalars. So now we have length of B squared, and then A dot A minus the scalar A dot B. And then what we're going to have here now is A dot B. And then observe though that A dot A here, okay, that's the square of the length of A. Yeah. And so that ends up being multiplied to the square of the length of vector B. Minus, all right, look now, A dot B, so that's a scalar, and then A dot B. A dot B, and then squared. This time, that square is not ambiguous because A dot B is a scalar. So if A dot B is 7, then that's just 7 squared. So the exponent there is perfectly placed. Now, we are now going to use this. Okay, and make that replacement here. minus. And then what are we squaring? In blue, so the length of A times the length of B multiplied by cosine theta. Can you see what's going to happen next?
I think
So
baka
meron
maano po yan, yung
may common factors.
opo, may common factor na yung absolute value AB.
All right, squared. And then matitira 1 minus cosine squared theta, which of course is
It's definitely not the real trigonometric function sine squared.
yeah. All right, so ito na meron tayo. A cross B squared equals square the length of A, then square the length of B, and then the square of sine theta. And then when you take the square root, A cross B equals the length of A, and then the length of B, and then dapat the absolute value of sine theta to guarantee that everything is not negative, but then this is just going to be sine theta.
So the area of a triangle formed by vectors AB is equal to the cross product of A and B
divided by 2. Right. Since the theta is from 0 degrees to 180 degrees, so sine of theta is greater than or equal to 0. Sige, punta tayo dun sa areas of parallelograms, and in fact, also, well, triangles, because that's what you talked about. But then number 3, let's just get this over and done with. A cross B is the zero vector if and only if A and B are parallel to each other. Okay. So actually, we've already seen a situation where the cross product turned out to be 0, and that happened when A and B were the same vector. V cross V is always going to be the 0 vector. Okay, but actually the more general situation is that the two vectors don't have to be the same as long as they are parallel to each other. Of course, V is parallel to itself. Okay, but in general, as long as parallel, the cross product is going to be 0. Okay, so nung proof nito, if A, well, kasi what does it mean pa for two vectors to be parallel to each other? It means that A and B are scalar multiples of each other. Okay, so for example, if you look at 3, -2, 1, this is parallel to 12, -8, 4. Okay, because the latter vector is 1/4 of the first one, and vice versa, the first one is 1/4 of the second vector. Okay, so itong cross product, idea na lang, actually follows from the previous statement kasi, so idea na lang, okay, if the two vectors A and B are parallel to each other, there are two scenarios, okay, and none of them is the 0 vector. Okay, and none of them is a 0 vector. Nung 0 vector kasi, trivially, you can think of that as parallel to any vector. Kasi, the 0 vector is the scalar 0 multiplied to 3, -2, 1. So the 0 vector is trivially parallel to 3, -2, 1. All right? Pero, well, kasi if the zero vector is involved, then it's parallel to any vector, and its cross product with any vector is the zero vector na rin naman talaga. So you're gonna
Well,
say, Joshua?
by that same reasoning, it should be perpendicular to everything that
Actually, yes. Yes. Actually, yes. The zero vector is also orthogonal to any vector because its dot product with any other vector is the scalar zero. So it's a special vector. It's parallel to anything and it's perpendicular to anything.
Crazy.
Crazy, right? Okay. So, idea na lang dito, and none of them is the zero vector. So, mangyayari, you have two possibilities. Okay, either they point in the same direction, so that means theta is 0, or they're pointing in opposite directions. In this case, the angle between them is 180 degrees. Okay, so that's what happens under parallelism. Okay, but then in both of these scenarios, what is the sine of theta? Sine of 0 degrees is
Sine
0.
of 0, and then sine of 180 is also 0.
So sine of 180 degrees is 0. So what we see here happening is that if A and B are parallel, then that means sine of theta is, if A and B are parallel, so that would imply the sine of theta would be 0. But then according to the previous property, if the sine of theta is 0, then that means the length of the cross product must be 0. But then the only vector whose length is 0 is the zero vector. So that means the cross product must be the zero vector. Vice versa naman. Suppose A cross B is the zero vector. Then mangyayari, if A cross B is the zero vector, so we're going to use statement number 2 again. Mangyayari, sine theta would be 0. But then that would mean theta would be 0 degrees or 180 degrees, which then means A and B point in the same direction or point in opposite directions, but either way, they are parallel. Okay. And then, hey, earlier you were talking about parallelograms. And actually, the area of a triangle. So ganito, number 4. Okay. If A and B are non-zero vectors, then the parallelogram formed by A, if A and B are non-zero vectors, then the parallelogram formed by A and B has area given by ayan, the length of the cross product. Okay. Proof nito. All right. Well, I suppose the first question is, what do we mean anyway by the parallelogram formed? So vectors, their positions are irrelevant. You could always move them as long as you're not changing the length and you're not changing the direction. But suppose you draw them so that they are starting from the same point. So they have the same starting point. So let's say this is vector A, and then this is vector B. So the parallelogram that's formed would then be this parallelogram. Okay. And then if we label the vertices as follows, P let's call this P, Q, R, S. Let's have a look at triangle QPS. The area of triangle QPS would be, using one of the area formulas, it would be the length of the sides multiplied, and then 1/2, and then the sine of the angle between them. So this would be 1/2 of the length of PO, and then the length of PS, and then the sine of the angle between them. But I'm going to take PO not just as the segment PO, but rather the vector PO and then the vector PS. Anyway, the side PO and the vector PO, they have the same length. Okay. But then from the previous statement, so PO, PS, adjacent vectors with theta, the angle between them, from not the previous statement, but 2 statements before. So the product of the lengths of 2 vectors, length of A times length of B, times the sine of the angle between them, is equal to the length of their cross product. So going back down here, we now have half the length of the cross product of the vectors PO and, sorry, did I say PO? I meant PQ. Sorry, I got confused by what I wrote down. Okay, that's PQ. PQ cross PS. Okay, but then for the parallelogram, the area of parallelogram PQRS, it will then be twice the area of the parallelogram. So here we go. PQ cross PS. So that's why. Okay. Was this mentioned before to you, Joshua?
People.
Huh? But you have an awareness of this property. So familiar ka dito or you've encountered it before?
Alam ko po yung ano ng, ito yung problem, diba? Yung problem, parallelogram. Nakita ko na po yun sa problem na sinol.
All right. So, ayun. Anyway, ayun. So, well, okay, apply natin dito. So we're given the following points: A, 520, B, 261, and then C, 247, and then D, 506. Show that A, B, C, D is a parallelogram and find its area. Okay. So we don't intend to draw this in 3-dimensional space, but let's say, just so we can visualize, let's say this is A, and then this is B, and then this is C, and then this is D. So we want to show that we have a parallelogram out of these 4 points. Okay. So what defines a parallelogram is that AB and DC must be parallel. AD and BC must also be parallel. All right. But when you have vectors, we have an easy way to determine when 2 vectors are parallel. All we got to do is show that they are multiples of each other. That would be enough to show that 2 vectors are parallel. I know we had this property with number 3, which says that, hey, parallelism of 2 vectors is equivalent to their cross product being 0. But actually, this is just for theoretical purposes. If you want to show that 2 vectors are parallel, you just need to do it by inspection. is there a scalar multiple that exists between the two of them? Don't take the cross product. That's a nuclear option, unnecessarily more tedious than just comparing. Ito, 12 is 4 times 3, -8 is 4 times -2. That's enough.
Why
Then
not,
4.
use advanced calculus.
All right, ito, let's take the vector A, B. Do you remember how to do it? We take, so A is the starting point, B is the destination. So when we take the differences, it's going to be the coordinates from B. So 2 minus 5, and then 6 minus 2, and then 1 minus 0, which would be -3, 4, 1. How about DC? So starting from D, going to C. So the coordinates for C are 2, 4, 7. So we start with them. Oh, hey, 2 minus 5, 4 minus 0, 7 minus 6, which would give us -3, 4, 1. So clearly, AB and DC are multiples of each other. In fact, they are equal to each other. DC is 1 times AB. AB is 1 times DC. And in fact, we're anticipating AB and DC should be the same vector because from the way we drew them, they're supposed to point in the same direction. That's why we chose DC instead of CD. Okay. And then, well, they're supposed to have the same length. So, ayun, clearly they have the same length because they're the same vector. Joshua, I don't know if I already asked you this, but do we need to compare AD and BC, or what we've done, would that be enough?
Okay, enough na po yun, I think.
Yeah, that's enough na kasi and well, how do we know that we don't have a trapezoid? Well, kasi AB and DC are equal to each other.
I mean, obviously po, so parang parang it's already given.
Yeah. Then A, B, C, D is a parallelogram. Okay, so the fact that AB and the DC vectors are the same, it means that AB has segments and DC have the same length. So they have the same length, and also they are parallel to each other. And that's actually enough to conclude that ABCD is a parallelogram. Because even if you're just able to work on verifying the parallelism between one pair of sides, pero mangyayari niyan, it can be proved that the other pair of opposite sides, they're also going to be parallel. Have I talked about this before?
Hindi po.
In there, all right. Kasi what if the other two sides, what if they're not parallel? That means if they're not parallel, they're going to meet.
Yes, okay.
P, Q,
Okay,
R.
okay.
Okay. So mangyayari di ba nung PQR would be similar to PST. Pero mangyayari, QR would be shorter than ST. Which is not the case here. QR and ST are actually equal. So contradiction, which means that meeting at point P is inconsistent with reality. So SQ and TR are not going to meet, which means, well, they're parallel.
Sinabi na po sa kanya, you are inconsistent with reality.
Yeah. Bummer. All right, burn. You're inconsistent with reality. Okay. So, okay. Parang, I do not question your incompetence. I deny your incompetence. Okay. And then for the area, since we already have AB, the vector AB, kailangan na lang natin ng vector AD. Okay, vector AD would then be, so starting from A, going to D, so 5, 0, 6, and then 5, 2, 0, so 5 minus 5, 0 minus 2, 6 minus 0. This is 0, negative 2, and 6. Okay, so now let's take the cross product AB cross AD. So I, J, K, AB is negative 3, 4, 1, 0, negative 2, 6. So I goes with 4, 1, negative 2, 6, minus J with negative 3, 1, 0, 6. And finally K with negative 3, 4, 0, negative 2. Joshua, what's the first determinant?
So wait, AD 4, 6, 24 minus 2. That's probably 13. And then
No, come on. What was the first determinant?
24 plus 24 plus 2, that's equal to 13.
Ah, okay, sure. 26. All right. This is
And then negative 3, negative 18, and 0. That's
mhm.
equal to negative 18. And
Nasulat ko
then
na eh. Then this is
negative 3 times 2 plus 1 minus 1 plus 1 minus 1 is equal
okay,
to
tama. Okay.
ito na.
So tama ng pares. All right. So I have the vector 26, negative 18, and then 6. So students ask, how do you know it's AB cross AD and not AD cross AB? In the end, it's not going to matter because it's not the cross product itself that we need, but the length of the cross product. So kung magka-switch no order, you're just going to end up with the negative of, well, with the other order, but then the negative sign isn't going to matter when you take the length anyway. Okay, but instead of, well, these are rather large numbers. Observe that sayang no 26 hindi divisible by 6. The only thing we could factor out is 2. So 13, negative 9, and 3. So the length of AB cross AD is going to be twice the length of 13, negative 9, 3. Always easier to find the length of a vector if the coefficients are smaller. So this would be the square root of 169 plus 81 plus 9. And so we have twice the square root of 169, and then 81 plus 9 is 90. So 9, and then 259. So that's the exact area, 2 times the square root of 259. So that's the area of the parallelogram. Ito, try.
No, but when I forget to specify that it is a rectangular quadrilateral, but I instead only say it's a quadrilateral. The try.
Try. There. Oh, meron akong ipapatry pero I don't have the details with me right now. Are they in my phone? Oh gosh, I think I deleted it earlier. Nag-clean up ako ng pictures.
Yung ano po,
Alright.
yung recycle bin.
Thinking. I have the questions somewhere. Wait, I may have the questions somewhere.
Baka hindi kaya po nasa recycle bin.
Kasi ngayon ko lang naisip. It's on my cell phone eh. I don't know how to access the recycle bin
Nasa
of a cell
photos po,
phone.
hindi kaya po meron usually po may recently deleted sa pinakababa.
Oh. Next time na lang. Wait. I'm gonna give this one more try.
Ouroboros.
One more try. All right. Ito, found it. Okay. So we're given 4 points: A, 0, 1, 2, and then B, 0, 2, 5, then C, 2, 1, 6, and then D, 4, -1, 4. Check 0, 1, 2, 0, 2, 5, 2, 1, 6, and then 4, -1, 4. All right. So what we gotta do is following. Show that A, B, C, D is a. They see the figure that I drew around the word try?
It's a square.
Yes, it's a square. No, it's a triangle. So show that A, B, C, D is a trapezoid and then find its area.
Yun po yung mga nagano po ng ano yung gumagawa po ng mga mathematical figures. This kind of looks like a square. I think it's good enough for the figure.
Thought it was a circle. Okay. So show that A, B, C, D is a trapezoid and then find its area. Okay. I'm almost done with the discussion on cross products. Pero ano, can we just how about we continue this another time na lang? Kasi kung magsisimula ako, mas ano mahirap mabitin.
Bitin, opo.
Mabibitin eh. Alright, bawi na lang tayo sa mother tongue. Alright?
Opo.
Okay, para din makapagpahinga na kasi nagbisita iglesia po po yata tayo kanina. Alright? Okay, so thank you. Bye.
Pag kino-compare ko po yung ano yung mga thank you po for yung mga lessons yung mga sabi nga rin ng isang teacher ni Joshua. Swerte ka rin Joshua kasi kung meron palang we were given like this when we were younger. Mas namin.
Alright.
Sabi ko para swerte mo naman Joshua. Kumbaga yung pagkain ng utak mo mas masustansya. Yung binibigay niyo pong lessons, kumbaga sabi ko sa kanya, swerte mo, mas masustansya than the usual.
Wow, salamat naman po. Anyway, and I think if or whatever I'm able to offer, it's no mga opportunities for nung problem solving session like nung kanina. Kaya parang how to attack the problem. So parang we're going through the thought processes involved. All right. Okay.
Thank you po.
Have a good evening. Bye-bye.
Thank you po. Bye-bye po.